Hey guys, welcome to Coronavirus Earth Science. We are on weather day 8, and today we're going to talk about things that affect the rate of evaporation. Now, I know I shouldn't assume it, but I'm pretty sure you guys know what evaporation is. This is when water goes from liquid to gas, and we'll get into that in a second, but what are things that are going to speed that up or slow it down? Okay, your grades for this week, here we are. Again, I've been reminding you every single day. You got your Castle Learning homework grade, and you have your Google Form quiz grade that I will be checking Saturday. Please make sure that you get them done. Okay. So how can we increase the rate of evaporation? Here's your little review of your water cycle. You guys should know your water cycle, right? Evaporation, adding moisture to the atmosphere. Condensation is forming those droplets again, right? Going from gas to liquid. Precipitation is your rain. Runoff is when the water flows downhill. And then kind of repeating the cycle. We'll get into groundwater and infiltration and all that stuff later on. Okay, so these questions, we actually did these already, but let's just review them again just to make sure we know what's up. Which map represents the normal location of high and low pressure belts? So this is your reference tables, page 14. Low pressure should be the equator, because it's wet, okay? And then it should alternate going out from there. So it should have been 4. And then here for this one, they're asking you where would the dry sinking air be? So here they're asking where are the high pressure locations? That's going to be 3 on the 30s, again, according to the reference table page. And then number 3, planetary wind and moisture belts indicate large amounts of rainfall. That's a low pressure system because that W stands for wet, all right? Loco, converging, and if it's warm, it's rising, okay? Remember, if you know the difference between your high and low pressures, you are good, all right? Please make sure you know your stuff. Okay, so how does water enter the atmosphere? So water going up into the atmosphere from Earth, you got your evaporation, which is liquid to gas, and this is going to come from your bodies of water. So things like oceans, lakes, puddles, streams, right? This is adding water to the atmosphere. Then you have transpiration. Now, you guys should have learned this in living environment. This is basically evaporation, right? Water vapor going up into the atmosphere, but this is coming from biological activity of plants. If you remember the guard cells and the stomates, right? The guard cells will open and release some of that water out into the atmosphere. So both of these add water to the atmosphere. Okay, this little diagram right here, this is from your reference tables, page 1, and it's just talking about the amount of energy needed to either to be gained to do a phase change or to be released in order to do a phase change, right? You got melting, freezing, evaporation, and condensation. So the ones that are gained are the ones that are getting hotter. So melting and evaporation are things that require you to gain heat. And then things where it's being released are the things that are getting colder. So freezing and condensation. And notice, opposites, right? Melting and freezing are the opposites of each other. They require the same amount of energy, 334, right? So just whether you're gaining or losing it. Evaporation and condensation are the same amount of energy. It's just a matter of if you're gaining or losing it. And notice what it says in the unit, joules per gram. So if I said 2 grams of something and how much energy needed to be gained to melt it, well, to melt it, it's 334, but look, that's per gram. Okay, so I would take that and I would multiply it by that. Okay, and if I did that, my answer would be this, right? And notice what happens to the grams. They canceled out. So that would be my answer. Because if it's joules per gram, we just said it's 2 grams. So I had to multiply it by 2. And same thing for the other ones. If it said 10 grams of a substance freezing, I would take this and multiply it by 10. If it said 15 grams condensing, I would take that and multiply it by 15. Okay, pretty simple. You don't get many questions on it, especially math type questions. Usually they just give you one of these numbers and they ask you what it's talking about, melting or freezing or evaporation. All right, so here's your water cycle. Again, evaporation adds, transpiration adds to the atmosphere. Condensation, so these guys were liquid to gas. Condensation is gas to liquid. Okay, so that's forming the droplets because it's colder. And then you have your precipitation, which is when it comes back down. And then you have runoff, which is when it flows downhill due to gravity. And then, just to give you a little precursor, once you have your water on Earth like this, sometimes it will infiltrate and seep in, and sometimes it won't, and then it will be evaporated back up, okay? And then it forms that water table down here. But we'll get into that later on in climate. Okay, so how does temperature affect the rate of evaporation? Well, if you take water and you heat it up, is it going to be more likely to evaporate faster or slower? All this stuff is common sense. I know that you guys get it. Just don't think of it in terms of crazy vocabulary. Just think, if I take a glass of water and I heat it up, is it going to evaporate faster or slower? And it's going to be faster. All right, so if temperature increases, rate increases. So that is a direct relationship. All right, so as temperature increases, rate increases. Big thing to know. Next one, wind. All right, so if I take water and I take a fan and I shoot a fan over it, or if it's on a windy day, is it gonna evaporate faster or slower? You guys know, common sense. Everyone's been to Disney and Six Flags. On those hot days, what do they sell? Those little water bottles with a little fan on it, right? All the cool kids had those. My parents couldn't afford it. I spent $20 for a little water bottle with a fan on it, right? But essentially, you're spritzing some water on someone's face, and then the fan is creating that evaporation a lot faster. Evaporation is a cooling process. It removes heat from a person's body. That's why we sweat, okay? So here, if you increase wind, you increase the rate of evaporation. Same thing if you're watching the NFL on the sidelines during those really hot days. A lot of the football players on the sidelines, on the benches, they got big giant fans and misters, and that's to increase the rate of evaporation and cool the players down. Next, surface area. We know this. Surface area, if you increase the surface area, you're going to increase the rate of evaporation. So the best thing that I could give you for this, if you have a glass of water versus if you took that glass of water and spilled it all over the floor, which will evaporate faster? If it's spilled all over the floor, it's spread out. It's got a lot more surface area. It's exposed to more wind. It's going to evaporate faster than if it stays in that glass. In class, we got those crappy brown paper towels that don't absorb anything. Usually all you do is spread it around on your table and it'll evaporate eventually, faster than if it was just together in that little puddle that you originally had. All right, so again, you take water in the long cylinder or in the flat dish. This has more surface area, so it's going to evaporate faster. Last thing, the amount of moisture in the air. So if you have a glass of water and it's on a dry day versus a hot, humid, sticky day, which one will evaporate faster? So this is the only one that is going to be your indirect relationship. If it's humid out, that means that there's already a lot of moisture in the air. So picture the air as being a sponge. The sponge is already filled with all that moisture. It's not going to want to add more moisture to it. So it's going to actually slow down here. All right, so as there is more moisture in the air, the rate of evaporation actually slows down. All right, so here's your summary questions. Which event is a direct result of transpiration and evaporation? So both of these are adding moisture to the atmosphere. That would be 4, right? Number 2, which graph best illustrates the relationship between the rate of evaporation and temperature? If it gets hotter, evaporation happens faster. That's a direct relationship. All right, so over here in your OneNote, this was your note sheet, so you should have had that all filled out with your do now questions. This is the worksheet that I would like you to get done. Again, it should go right with the notes, should be easy to fill in, and get that done. All right, do not forget to get your CASA Learning done, and do not forget to do your Google form. All right, guys, that's it for this week. Hope everyone has a great day. Stay safe, and miss you all a whole bunch.